We're back to a sort of chart problem that is involving mixtures and work, some of which have percents in them. The problem that I've written out is in a longer version on page 321, so you might want to, actually I would listen to this first and then pause it and look on 321 if you're having a hard time. Basically, this is not a whole lot different than chart problems we've done before, where if I know how much, how many, in this case, kilograms, and I know how much each kilogram costs, I can figure out the total cost. That is not different at all. So, in this problem, we have raisins, we have nuts, and we have the mixture. So as always, we want to start with what we do know. We know that raisins cost $3.50 per kilogram, and we know that nuts cost $4.75. And in this case, there's a third row that talks about the mixture, and we want that to be $4 per. We also, when we're talking about how many we have, we know we want a total of 20 kilograms. So if I call raisins X, I hope you remember that nuts needs to be 20, the total, minus X, the part that is raisins. It's everything that's left is 20 minus X. And we know that the mixture is 20. So since kilograms times price per kilogram gives us the total cost, we don't know what this is in raisins, but we know that it is a variable expression equaling 3.5x. And we know that this is a variable expression, hopefully I have room, 4.75 times 20 minus x. And 20 times $4 is $80. Unfortunately, I have to turn the page, but before I do, let's just take a look. If this is the part that is the cost of the raisins, and this is the cost of the nuts, and we want it to cost $80, it's pretty clear what our equation should be. The cost of the raisins, 3.5x, okay, it wasn't ready for me yet, 3.5x, plus the cost of the nuts, 4.75 times 20 minus x, equals the total cost, which is 80. You all know how to do this equation. You might want to do the decimal destroyer, since I want to get rid of one. Well, actually, I want to get rid of 2 decimal places. Yes, I want to get rid of 2 decimal places, so I'm going to multiply by a 1 with 2 zeros, otherwise known as 100. So this is 350x. You don't have to do this, but 475. It is my experience that people make fewer mistakes when they get rid of the decimals. And don't forget, whatever you do to one side, you have to do to the other. The rest is really, you know how to do. I'm going to tell you that it comes out to x equaling 20. Oh, sorry, x equaling 12. We said that x was going to represent the number of raisins. So x equals the raisins. And we were looking for a total that was 20 minus x is going to equal 8, which is, these are the raisins. And these are the nuts. In 8 kilograms. Okay, so that's one whole type of problem. The next involves percents, and on these, I really do need you to think. The mixture problems aren't that different from what we've done in the past. In the percent of new things that you need to think about. The problem is talking about an auto mechanic who has 300 milliliters of battery acid. I'm just going to say acid to save space in the writing. And that is 60% acid. He wants to add water to dilute it. How much water needs to be added to dilute? That means make it less acidic. I hope you know that from science. To being 45% acid. Now, this isn't a chart that we've done before, but we have talked a little bit about how, if you know how much of something you have, like let's talk about this. I will tell you that there's the original solution, there's the water added, and there's the new. So, and we know how much we have, the amount times the percent acid gives us what? Can you figure that out? Yes. It gives us how much actual of the thing is actually acid. So in this original thing, I've got 300 milliliters, and it is 60% acid. Let's just write that as a decimal, because then right in your calculators you can say 300 times 0.6, because 60% of 300 is 0.6 times 300. Lots of you can do this. You know a tenth. 10% is 30. So 60% is 180. Okay, that part, since there are no variables, we can do. We don't know how much water we're adding. Okay? Now the question you have to ask yourself is, what percent of water is acid? And hopefully, if this is something that we are drinking, it will be 0. So we're not adding any acid. The new solution is going to be the original 300 milliliters we had, plus however much water we added. And as stated in the problem, we want that to be 45% or 0.45, 45 hundredths acid. So the variable expression for that is 0.45 times 300 plus x. Okay, this is where we really have to put our thinking caps on. 45% of the new solution is going to be this 180. Since this is talking about the acid, we haven't added any acid. So that amount of acid, 180 milliliters that we started out with, that's all of the acid. We want that much acid to be 45% of the new solution. We don't know how much is in that solution, but we know that it is 300 plus x. And when you solve this equation, and I'm not going to do that part, you can do it however you want. Personally, I would suggest that you multiply by 100 first. When you solve it, you will find that x is equal to 100. And that's how much water you need to add to make the solution 45% acid. In the problems that follow, some tricky things, okay? Just like water is 0% acid, in some of the problems, you're adding juice. If you're talking about adding juice, is juice? Well, it's 100%. So if I talk about, in number 3, it says there are 800 milliliters of a juice drink that is 15% juice. And yes, if you do look at over-the-counter things, it's true. Those things that you drink that are called juice are really it's only 15% juice. Okay, I'm sorry, I'm trying to write an is. How much juice added to make it, what do they want? 20% juice. Okay, I know that's cryptic, and it's short. The problem is written out in your thing. But We've got the original, we've got the juice added. How should I fit that? Juice added. And we've got the new. And with this, if we know how much we have, and we know the percent juice, it will tell us how much juice we have. In the original, I have 800 milliliters that is 15% juice. I think you all know that 10 is 80 and 5 is 40. So when you do that, you will find out that that is 120. When you've got the juice added, that's what you don't know. That's X. And here you have to ask yourself, what percent of juice is juice? It is 100. The decimal for 100 is 1. So again, we're adding X amount of juice. Now the new solution is 800 that we started with, plus the amount of juice we don't know. And we want that to get to be 20% juice. So this will be 0.2, because 20 and 20 hundredths is the same as 2 tenths, times 800 plus X. And this is slightly different. We want this is a variable expression that tells us how much juice is in the new mixture if it is 20%. So we want that 20% of 800 plus X to be the amount of juice, which started out as 120 milliliters, and we added a certain amount that we don't know. And again, now we can multiply by 10, making this 2 times 800 plus X. And if I'm multiplying by 10, I have to multiply each of these terms. So it's 1200 plus 10x. And I will leave the solution to you. These can be hard. Be patient with yourself. Go back to the the examples. And some I haven't shown you exactly how to do, but they're like coin problems or investment problems that we've done in the past. So good luck.